Hello, I'm Robert Henderson. I'm a solutions specialist with the Transportation Asset and Network Performance team at Bentley, and I'm going to talk about asset management, its policy, and the strategic decision making really to drive asset performance in today's tech talk. Now, this is a four-part tech talk series. Today is part four. Um, the first three parts are available on demand. So the introduction to asset management and its strategy was part one. Part two is the strategic approach to the asset management system. And then part three was really exploring the business benefits of asset management. And today I'll be talking about the asset management policy, how policy drives the strategy, and then the strategic decision making to really drive asset performance. And today I'll be talking for about 35 to 40 minutes during this presentation. And again, all Tech Talks will be made available on demand after their completion. So this will be made available. Today, I'll be talking about the asset management policy, the organizational strategic plan, and the asset management linkages to it, right? And the importance for that linkage. I'll go through some life cycle cost management, risk management, and then performance management to drive the performance of our assets. This here is a very high view of the asset management system. It's looking at it in a very simplistic way. However, when we look at the asset management system, the asset management policy is an enabler for the management strategy, which is an enabler for the asset management objectives, which are enablers for the plans, which enable the implementation and managing of our assets. So the path is the line of sight aligned with the organizational strategic plans and objectives, which would sit on top of the policy. So from this perspective, when we look at the asset management system, the policy seems to have the greatest importance. However, I'm going to talk about this in a little bit more detail with the ISO 55000 graph. Today, I want to focus on four key elements. And the purpose, again, the purpose of the organization, right? So we are in business to provide something, and these are the high-level goals to be successful. So this is the organizational plans and objectives that then would drive the strategy. Now we talk about the line of sight, the alignment, or what reliabilityweb.com calls the aim. So without alignment, there's a risk that the asset management will fail because we need that organizational alignment to ensure we're doing the correct things. So the enablers, so the policy enables the strategic asset management plan or the SAMP, for example. So it has to be aligned. The policy really is an enabler for the SAMP. And of course, the fine correction is required for continuous improvement. So if an organization can't continuously improve or adjust properly to external or even internal forces, then the organization will obviously become obsolete. So as highlighted on the screen, the purpose, it shows the organizational strategic plan, which sets the direction of the asset management policy and the asset management system. And then likewise, the bottom upwards monitoring of asset characteristics, problems, risks, and opportunities should provide the factual basis for adjusting and refining realistic asset management strategies and plans through a process of continuous improvement. Additionally, such asset management realities should inform and influence the expectations of stakeholders and the aspirations of the organizational strategic plan. So we did go over that a lot in the previous tech talk. So let's review the asset management policy in more detail. So as we can see here, a policy is the intentions and direction of an organization as formally expressed by its top management. So the asset management policy provides the framework around the asset management strategy, objectives, and plans, which are developed and implemented. So a good place to start when considering what to put in your asset management policy is simply by considering the mandatory requirements of ISO 55000. So when we look at top management in a little bit more detail, what is it? Top management is in turn defined as being a person or a group of people who directs and controls an organization at the highest level. So top management demonstrates leadership commitment by, amongst other things, ensuring that the asset management policy is established and is compatible with the organization's overall business objectives. So top top leadership involvement in the development of the asset management policy is extremely important. So the scope of the organization's asset management system should be aligned with the asset management policy. As far as ISO 55000 is concerned, the asset management system is the management system for managing the organization's assets. It is used by an organization to plan, coordinate, control, execute, and monitor and improve the activities associated with managing assets. It is not just a computerized information system, although this may be part of the organization's asset management system. So consider your asset management policy as being similar in nature to your organization's safety policy or environmental policy or sustainability policy. So an asset management policy is applicable to any asset intensive industry, which is especially true for transportation organizations. But what are the requirements of this asset management policy? How do we develop it? Um, so we can look at the asset management policy to drive the strategy. It must be aligned with the organizational strategic plan of the organization, of course, and this linkage is required to ensure success. So that linkage is very important. Now let's take a closer look at the linkage between the organizational strategic plan and the asset management policy. So to deliver the demands of the organization's strategic plan, the asset management policy typically needs to cover the following areas: knowledge and information, whole life costing, asset risk, audit and review, and process and systems. So this can be mapped to the asset management landscape and the 39 elements defined by the Institute of Asset Management, which are associated with the asset management system. So these 39 elements from IAM were covered in the previous Part 3 Tech Talk, which is available on demand if you want more detail on that. Now, when developing policy, some organizations group things into themes, right? It makes sense. Let's use these typical themes as our policy themes, and then um, let's look at how it will impact the asset management system. So we need to look at customers, customer satisfaction, very important in transportation, shareholders and their expectations, safety and social responsibility, um, employee satisfaction as well. The asset management system and maturity is the asset management system capable of continuously improving. Compliance, we need to comply with regulatory requirements, especially very true in many industries, and risk management. And I'll talk about risk management in a lot more detail later on in this presentation. So taking the themes, we can then drill down deeper into the policy. So we need to establish the link between the themes and the asset management and its impacted areas. So we need to validate our theme selection to ensure that they are aligned with the business operating model. Identify key areas impacted, identify and develop objectives at a very high level, define deliverables for realistic and achievable objectives, set clearly understood targets and goals for deliverables, and always have the continuous improvement process, vision, and strategy in mind. So this is all easier said than done. So a great policy example is actually a one-pager, and it was derived from the New York MTA. And this policy has actually been used internationally to help organizations develop their own policies in more than just the transit industry. So this is the policy, 7 points there. So safety is and always will be our number one priority. The reliability of our assets and the technologies we use will be optimized to deliver the system capacity, capabilities, and schedules we are expecting to achieve. We will provide safe, reliable, clean, and accessible transportation services as well as timely and accurate service information to deliver the customer experience our customers deserve. We will invest our capital and operational funding effectively and efficiently, ensuring that every dollar spent is based on criticality and risk to assure value for money. All investments will consider the sustainability and resilience of our asset base to sustain a state of good repair, meet current and future service demands, and also consider the long-term societal and environmental impacts. The women and men leading our organization will be enabled to continuously improve their knowledge and skills. We will ensure and be able to demonstrate compliance of everything we do relevant with regulation, legislation, standards, and industry codes. Right? It is important to note that the CEO signed this policy. It is a statement. It's not an action. It is a declaration, as Reliability Web calls it. This declaration will enable the action of asset management and reliability. Policy enables asset management to succeed. And I know, okay, enough about policy. Let's talk about life cycle and asset performance, and that's what I am about to do. So this here is a great slide, in my opinion, to talk about life cycle. There could be an entire tech talk talking about life cycle, so if you're interested in that, submit that as a comment. To summarize, though, over the life cycle of an asset, about 80% of the total asset life cycle cost is during the operate and maintain phase. So managing the performance and reliability is obviously critical. So optimizing processes for day-to-day running of the assets, we can minimize operational cost and maximize our production capability. And this is a key component of TOTEX, which is the total life cycle cost. This helps drive profitability of our transportation networks. But the reality is that TOTEX is baked into the asset at the time of design. And to quote some of the experts, they say about 70% of the overall operational value is actually designed in. So design for reliability makes sense. As the real story behind this slide is the value is not created when the asset goes into service. The value starts when demands on the asset are placed, which starts as early as conceptual design. So if you boil down past 55 and ISO 55000 for asset management and ISO 31000 for risk management, BS 1192 or ISO 19650 for building information modeling or management, they all speak to information and context and delivering value from design through to end of life. It's really about information line of sight. So if we place the wrapper around this model, we can refer this to as enterprise configuration asset lifecycle information management, which remains critical for ensuring reliable, accurate data throughout that full life cycle. Now, up on the screen, okay, which bus should I buy? I mean, these examples I just threw on the screen, but there'd be obviously more details for that requirement. But companies are interested in life cycle cost analysis so they can, um, understand which option or which new piece of equipment, new building, which new bus is the best option. So when defining the best, it is important to clarify what we mean by best, and that always depends on the organization and its objectives. So it can be, about minimizing the total life cycle cost of an asset or its complement, maximizing the total life cycle benefits of the asset. So the iceberg shows obviously that there's more cost than the upfront acquisition, and the total cost can be many times greater. So in the airline industry, for example, life cycle cost of an aircraft can be 5 times the initial purpose. Even computer hardware is another example that has a lot of hidden costs. And one organization stated that 85% of computer costs are usually hidden going to administration costs, operations costs, and the bulk, about 56% of that, to asset management and service and support costs. So the role of life cycle costing is to influence and improve the quality of asset management decisions. The type of problems for asset management and the cost are usually the three on the screen. So when we look at technological improvement, due to some sort of technology improvements, assets with better performance and lower operation and maintenance costs might be entering the market. So the rate at which technology is improving enters the market depends on obviously the type of industry and the pace of the technology improvements and innovation. Um, in these situations, it would be valid to ask, when is the best time to replace the current asset? Or in other terms, what is the economic life of the current asset? So optimum replacement age, when is it the best time to replace an asset at the lowest overall cost to the organization? And that gets into the repair versus replace. When assets are new, typically their operational costs are low and they're more reliable. Over time, as assets age, usually the cost will increase. So we need to ask if we should keep repairing an asset or should we just simply replace that asset, and when is the best time to replace? So that's what life cycle costing gets into. And as assets are used for a longer period of time, um, the 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 annual capital costs um, basically spent can decrease. So in this ownership cost would decrease is what I'm talking about there. So in its simplest form, the ownership cost can be thought of the purchase price of an asset minus the resale value at the time of replacement divided by the replacement age. As a result, organizations tend to utilize an asset as long as possible, thus reducing ownership costs unit per unit of time. On the other hand, the annual operational maintenance costs, the cost of lost production due to equipment breakdowns, consumed energy, tend to increase as the assets get older. So the total cost of keeping the assets operating is the sum of the two costs, one usually increasing, one usually decreasing, and then we have to find that medium point, and that medium point is the optimum replacement age. So the age at which the total cost is minimized is called the economic life of the asset, as shown on the graph. In addition to increasing and decreasing costs, there also needs to be taken into consideration the fixed cost. There's obviously no increase and decrease to it, but we need to take into consideration the fixed costs for budgetary reasons. So we need that figure as well. So a little bit about risk management. What is risk? If we check the meaning of risk, it's the chance of injury, damage, or loss. As a verb, it means to expose to the chance of injury, damage, or loss. Now, risk is a product of probability and consequence. Therefore, two apparent different situations can occur. One with a high probability and low consequence. This could be tripping on uneven pavement and getting injured because of it. And another one would be low probability and high consequence. And an obvious one would be an aircraft crashing. So these can actually have similar risk values. So we need to take into consideration cost, safety, environmental impact, and reputation consequences. It is, only a human habit to focus more on high consequence events, even when they are very unlikely, than those that have little impact but have high chance of probability. So even, the most experienced maintenance professionals tend to have this bias. So a major equipment failure represents an extreme need to manage maintenance risk. So the production downtime could delay needed services to the customer and could cost the business in terms of loss of revenue. There could be further losses if the equipment failure threatened the safety of employees or adversely affected the environment. So the key to asset management is to have an integrated system that defines risk down to the lowest maintainable level. An example is a failure mode, so the risk can be understood at the root. To make effective decisions about the risk management process, the risk team and stakeholders need to communicate frequently. There must be open dialogue to validate each step of the team's hypothesis to ensure that all stakeholders are involved. Since the process um, um, is to evaluate risk, it can be very time consuming and expensive, and it is important to invest the time only on the assets and processes really identified as the most critical. To reduce risk, there is generally far more to analyze than there are, time and resources available. So in addition, not all equipment deserves the same degree of analysis. To determine where the risk management effort should go, it is critical to understand the asset criticality. How critical is the asset to the business? Generally, you should determine the answer by the consequences if it fails and how often it fails. So a little bit more about asset criticality and asset risk analysis. So the best process of developing an asset reliability program is to look at which assets are a high risk depending on safety or environmental or performance based on your organizational needs. Then we need to develop a strategy with the understanding of our most critical assets. So we need to prioritize assets by consequence of failure, as shown by one of our clients on this screen. So for fleet management, HVAC is commonly known as a bad actor for failing at a very high rate. Although HVAC is important to customer satisfaction, it isn't safety critical, and depending on your weighting and your risk analysis, it makes more sense to repair or closely monitor the brakes or the door system of a locomotive first. So we need to use the best principles of reliability by looking at the POF and the COF, which is the probability of failure, and then the consequence of that failure if we don't maintain the assets prior to failure. So for example, we can drill into the data and see the failures over the past 2 years, and by understanding our assets, we can identify a probability of failure by using the collected data to forecast potential risk. When we look at the risk analysis, we also get a clear understanding of the consequence of that failure, right? So a braking system failing has a huge safety risk when we're talking about our fleet rolling stock. Not only does this hold a safety consequence, but it also creates risks with the business. An accident causing death or environmental destruction can cause significant damage to an organization's reputation. So risk analysis is one of the first steps when developing a reliability program, and it is absolutely key to develop a resilient asset strategy. Now this is a nice, cool little image of risk management and flood analysis for roads. So what we see here is a river, and we have a 50-year flood zone and a 100-year flood zone. And we're identifying which is at high risk, which is at medium risk, right? So clearly visible, and just a completely different way of looking at risk in transportation with linear assets. Much different than a sort of a risk analysis associated with a pump in a plant. Now, when we talk about performance management, key performance indicators, KPIs, are extremely important. So I listed four on the screen that are often used. It's planned versus unplanned. So ideally, you will have very little unplanned work. So with a designed maintenance program, you will know, what to do, what to expect, plan things in advance, especially for our critical equipment. So having a 95% of total maintenance labor hours planned is considered good practice. Now, scheduled compliance is a measure by dividing the total labor hours for all work completed as scheduled by the number or the total number of labor hours for all work scheduled in the same time. So for example, if we have scheduled work, 1,600 hours of work for a week, and we've completed 1,000 of those hours in that week, our compliance rate is around 62, 63%. So if compliance is high, then we're operating under control. So if it's low, then we're very likely to be experiencing excessive amounts of emergency work, and obviously when that happens we have higher costs. So 70% is considered a good performance number, but we all know we can do better than that. The key to obtaining high performance and avoiding firefighting is simply, excellence planning, accurate scheduling, uh, disciplined work assignment with execution, and of course a maintenance program that is mostly proactive. And I went through the business numbers in the third tech talk about if we increase our proactive base maintenance versus our reactive maintenance, what that actually does to the business and how much money we can save. So that's a very important metric to follow. And again, urgent versus normal purchase requisitions. This is just another test of maintenance planning. Our maintenance, repair, and operations, or MRO, inventory management, and the appropriativeness of our equipment maintenance tactics. And store stockouts, the percentage of inventory requests failed on requests. So we usually want to aim for a 95 to 97% availability. So it is important to remember that many stocked items have, little impact on safety or environment, but they could have huge impact on the operational performance, making something unavailable, creating downtime problems. So this here is a specific example of using dashboards and KPIs to calculate the mean kilometers between failures. So here we're trying to track KPIs set by the reliability authorities to compare how each corridor is doing. So we can compare the metrics between what corridor our rolling stock is traveling, whether it's our blue line, red line, XYZ line, or whatever you call your corridors, it doesn't matter, and to understand if the track condition is creating our assets to degrade faster. And in this case, we're looking at our fleet assets. So this is a top-down approach from a metrics tracking perspective. So we go from the overall track performance or line or corridor, and then we can identify the problem corridors and then drill into further analysis. It could be the corridor condition. Maybe it's not the corridor condition. It may be that the rolling stock in this area is a problem on these corridors, or maybe it's because there's a problem with maybe the traction power system on these corridors. But this is sort of that high level view of the information. So we need to see things at a high level, see the performance, and then we would drill down into it to find the root cause. So one layer of indicators would be at a corporate strategic level. A supporting level would be the financial performance indicator for a particular department or process. A third level would be an efficiency and effectiveness indicator that highlights what impacts the financial indicator have. A fourth level would be a tactical level indicator that highlights the departmental functions that contribute to the efficiency and effectiveness of the department. And a fifth level indicator could be a measurement of the actual function itself. And depending on the criticality of your assets, we may need to go into more advanced methodologies associated with reliability strategy development. So in terms of strategy development, when we look at a current practice review, it is where we start to create a baseline to get an understanding of what we're doing today. And when we determine what we do today, determine if it is valid, take that paper check sheet and make it electronic, document any procedures that are done by subject matter experts that are not documented today, digitalize that workflow. What do you currently do today with your inspections? How can we improve that process that's in place? As we mature more in reliability, the current practice review is really a functionality that will allow an organization to continuously improve. And as we mature, we can get into more advanced methodologies. A common one is root cause analysis. So we need to be able to support a root cause analysis and digitalize a process for it, so we can fix something at a root cause and document it properly, and then tie that into the strategy to optimize maintenance procedures in the future. And then one methodology is failure modes effects analysis, FMEA. So an FMEA solution is often a first step um, of a system reliability study. It involves reviewing as many components, assemblies, and subassemblies as possible to identify the failure modes and their causes and effects. So for each component, the failure mode and their resulting effects on the result of the system are recorded in basically an FMEA worksheet. Now, RCM, um, reliability centered maintenance, it's a popular methodology to achieve improvements such as establishing the safe minimums levels of maintenance. So it's defined by the technical standard, the SAEJA 10, 11, I believe. When successfully implementing an RCM program, an organization typically sees an increase in cost effectiveness, reliability, asset uptime, and a greater understanding of the level of risk that the organization is actually managing. So this also relates to improved safety, and we've seen very successful implementations of RCM in the airline industry to solve many of their safety related problems back in the 70s and 80s. So RCM is not a new methodology, but it is a methodology for a more mature organization. Now, support resources, I have some up on the board here. We do have several um, Bentley experts. If you want to reach out to me for more information on any of these tech talks, reach out to me, um, and perhaps we can get in contact with a specific SME for your needs. ISO 55000, the Institute of Asset Management as well, a good support resource, the IAM, and reliabilityweb.com. So they do have uptime elements. I went through a CRL workshop, which is a Certified Reliability Leader certification. So it's a certification through the Asset Management Professionals, the AMP, and they also offer now a Certified Maintenance Manager workshop. And of course, there's a lot of information available in their Uptime magazine. So thank you for taking the time out of your busy day to listening to me speak for about 35 minutes, 40 minutes. I hope you enjoyed my presentation. It was meant to be software neutral. And I hope you enjoyed the four-part Tech Talk series. If you want to send me a direct email, my email is on the screen, robert.henderson@bentley.com. If you want to connect with me on LinkedIn, my LinkedIn profile is there as well. I often post things that are related to Bentley, lifecycle management, and asset management, either as articles or postings. Again, thank you for taking the time in your day to listen.